All right, so this is going to be a video about the differentiation of a polar equation. So as you see right here, we have r equals cosine of 2 theta, and we're looking for the derivative at specific points. So we're looking for the derivative at theta equals 0, plus or minus pi over 2, and pi. First thing you're going to want to do is find the x and y value based on this polar equation right here. So that's what I'm going to do really quick. Your x is equal to r cosine theta. That should be reviewed in previous math classes. And then from here, we substitute our r in. So our r is cosine 2 theta right here. So I'm just going to write cosine 2 theta times cosine theta, something like that. Okay, and then you do the same thing with the y. The y is going to be equal to r sine theta. Again, that should be a review. And then from here, we're going to substitute our r in again for cosine 2 theta, and then we're going to multiply it by sine theta. Okay, so you defined your x's and your y's here, and the thing you need to know for finding the derivative of a polar equation is dy over dx, which is what we're looking for, is equal to dy over d theta, so the derivative of y with respect to theta, all over the derivative of x with respect to theta. Okay, and the reason why this works is because this d theta and this d theta will cancel out and you'll have dy over dx. So first thing we're going to need to do is find the derivative of this y right here with respect to theta. So we're going to find the derivative basically of this blue right here, and it looks like we're going to have to use product rule because we have a function times this other function here, as well as some chain rule. So f prime g plus g prime f prime is going to be negative 2 sine 2 theta times g, so that's just going to be times sine theta, plus g prime, which is cosine theta, times f. So it's just going to be regular f here, so I'm just going to write cosine 2 theta. Let's see this a little bit easier. Okay, and then all of this is going to be divided by dx over d theta. So we're going to do the derivative of this top part right here. I'll do that in orange. All right, so you have f prime, which again is negative 2 sine 2 theta. F prime g. The f's and the f primes should be the same, so these two f primes match. Plus g prime, which is negative sine theta, times f. So again, the f should be the same as well as the f prime because they both share this cosine, this part right here, this cosine 2 theta. All right, from here we are looking for the derivative at 0, plus or minus pi over 2, and pi. All right, so finding the derivative at these points, what I'm going to do is find the dy over d theta for each of these when you plug in theta to be that value. So what I'm going to do is I'm going to actually set up 4 different fractions because you have 4 different answers there. You have 0, pi over 2, negative pi over 2, and pi. Just kind of separate this out to make it a little bit easier for me. So if you plug in 0 to this top part, this red part right here, you're going to end up with 1. If you plug in pi over 2, you're going to end up with 0. If you plug in negative pi over 2, you also end up with 0. And then if you plug in pi to this top part right here, you're going to end up with negative 1. Okay, it's just really simple trigonometry. If you plug in 0 here, you're going to get 0 for this part. And then if you plug in 0, it's cosine of 0, which is 1, times cosine of 0, which is 1. So 1 times 1 plus 0 is 1. And you can kind of work those out on your own. The pi over 2 is kind of easy because it just ends up being 0 plus 0. Same with the negative pi over 2. And then if you plug in pi, the reason why you get negative 1 is because this whole part is 0 again, because sine of pi is 0, sine of 2 pi is 0. And then cosine of pi is negative 1. So it's going to be negative 1 times 1. So you end up with a negative 1 here. All right, so now I'm going to do the same thing with the denominator of this derivative right here. I'm going to plug in 0 to the bottom, and you should get 0 for that one. Okay, if you plug in pi over 2 to the bottom, you should get 1. If you plug in negative pi over 2, you should get negative 1. And then the last one, if you plug in pi, you should get 0. So this actually ends up getting your final answer here. you end up with, for the first one, the derivative at theta equals 0 would be undefined. The next two would be 0 and 0 because it's 0 over 1, 0 over -1, and then another undefined. So your answer is not very exciting, but it is the answer nonetheless. So you end up with undefined, 0, 0, and another undefined when you input these values right here. So that's basically how to do a polar differentiation problem when it's looking for the dy over dx of a given polar equation. If you have any questions on anything in this video, let me know.